Hi guys, welcome back to Matrix Uploaded. My name's Mark. Let's get into number patterns. They are such an important part of the syllabus. Okay, so grade 10s, 11s and 12s. Stay tuned in. Watch the program. It's very good for you. Let's look at a more difficult example quickly. When we talk, we're gonna pursue this and let's see what happens. Here we've got a very interesting number pattern with negatives, and it says determine the nth term, the thousandth, and which term equals this. Okay, now let me have a look at this. Okay, we've got from minus 6. What are we doing to go to minus 11? What do you think? Subtracting 5. Okay, so minus 6 minus 5 is minus 11. If you look at this one, we're going from minus 11 to minus 16. It's minus 5. And negative 16 minus 5 is 21. So we're kind of getting less. We're decreasing. The thousandth term is a bit tricky. And which term equals minus 751? Well, that's even more tricky. Okay, but don't panic. We've got a linear or an arithmetic number pattern, and we know what to do. Now, grade 10s, watch this. Of course, grade 12s, you've got your method as well. But check this. Let's have a look at it. Let's use the grade 10 method. What we've got here is we've got our number pattern. Okay, what's the constant difference there? Minus 6, subtract 5 gives you minus 11. We're getting smaller. Subtract 5, minus 16, and so we go. And we know that that's B, and that's B plus C. Or if you like, guys, matrix, A is equal to minus 6, and the constant difference is minus 5. And of course, you can then do Tn as A plus N minus 1D. But remember, we're starting now with this method because this is what grade 10 start off with. Okay, so what do we know? B is equal to negative 5, B plus C equals negative 6. So again, we know those, and we know what B is, negative 5, and bring that across. Negative 6 plus 5 gives me negative 1. Remember, it's negative 6 plus 5 is negative 1. Okay, and there we've got it. So what do we know? We've got B is minus 5, C is 1, and that's the rule that we use in grade 10 specifically, and we've got our minus 5n for B, and our C is minus 1. Matrix, you might want to go and try A plus N minus 1D, and if you multiply out, you'll get pretty much the same. Okay, don't go away, stay with us. Alternatively, let me show you something quite interesting. This is something that you might want to think about as well. Have a look at this. Do you notice something interesting here? The B, do you notice something very interesting here? The B is negative 5. And what was the C? The C was negative 1. If you say this minus 6, subtract negative 5. Negative 6, the first term, subtract the B. You get, in fact, negative 1. All right. So in other words, what you can do is once you've got your B, grade 10s, this is brilliant. Look at this. It's another way. You can go B plus C equals, but another way you could do it is you could simply take that first term and minus the negative 5. So whatever the B is, you simply say first term minus that thing. Now be very careful. You're subtracting negative 5. So negative 6 plus 5 is negative 1. And of course, you've got it, which is pretty cool. I found that quite a fascinating thing. Okay, now the next term, what it does is it gives you the formula you've got here, and you're going to have to work out a specific term. And we wanted the thousandth term. Well, once you've got the general term, your N is 1,000, and we plug it in. Okay, 1,000 goes in there. All right, and off we go. We work that out. Minus 5,000, and minus 1 is that. What a pleasure. Number C, they said to you, which term is minus 751. We want the N, the position. Well, you've got the term, so look at the slide. We replace it with minus 751. And all we now do is we solve the equation. So minus 5n, he pops to the left, and in other words, you simply bring him across, and the 751, you bring it across to the right. So in other words, what we do is if we bring this we add 1, we get minus 750 is that. Now simply swap them around. If you divide both sides by negative 5, the N is 150. So then it gives it to you, the position of the term. Okay. All right. Let's continue. Have a look at this one. You've got to determine the nth term and the 60th term. the nth term in the 60th, but this is a bit weird. And in fact, how it works is the first you've got a 1, 2, 3, 4, and then you've got a 3, 5, 7, and 9. Have a look. This is quite a cool one. If you look at this, you can take the 1, 2, 3, and 4 out, and you can take the 3, 5, 7, and 9 out. Okay, and let's look at the 1, 2, 3, and 4. Okay, it's linear. You've got b as 1 and b plus c as 1, and you then, of course, have b as 1, b plus c is 1, and we do pretty much what we know. B is 1 and c is 0 if you take it across. So what does that tell us? B is 1, that is that. Bn plus c, nothing in it, and Tn is 1, b and 1. Okay. All right, so just be careful with this. The next one, if we do the same with the 3, 5, 7, and 9, we get our constant difference. B is 2, b plus c is 3, or you can, and you see, look at this, 2 for b plus c is 1. If you go 3 minus 2, you get 1 as well. And you plug it in, b is there, c is 1, and you can put that in 2n plus 1. Now, what do we know? For that, the 1, 2, 3, and 4, we've got that. For the 3, 5, 7, and 9, we've got that. And all you have to do for the whole thing is you plonk, you put the n there, the 2n plus 1, and you've then got your general term. Guys, it's been great. Stay with us for some more maths on Matrics Uploaded very shortly.